Okay, hi. So I'm really pleased to be hosting my friend Len Schubert back here at Hopkins. I knew him when I was at University of Rochester, but it turns out that he did a postdoc here a number of years back, after which he spent many years as a professor at University of Alberta, which is a really great AI department, and after that, many years at the University of Rochester. There are a lot of people now who are finally starting to really try to do computational semantics, and most of them have kind of n-gram approximations to semantics. And Len is somebody who's been doing semantics in much more palatable ways if you're a linguist or somebody who really thinks that there's meaning in language for quite a long time. So the system of his that I know best is epilogue, there's episodic logic, and you can think of this kind of system as well as things that he's working on now and will tell us about, and some things before that, as ways of being able to formalize the meaning of a sentence or a paragraph in a way that you can then go and reason about. So I don't want to try to summarize his work because I won't get the new stuff right. So thanks, very glad to have you here, Len.
Thanks very much, Jason. It's a pleasure to be back here after a number of decades and rediscover JHU and the department as it didn't exist way back then. So yes, I'll be talking about the acquisition and representation of general knowledge about the world. And I use the term generic knowledge because essentially all of the general knowledge that we possess in the terminology of semanticists consists of generic sentences or generic passages. At least this applies to the verbalizable knowledge that we possess. So my interest is in the grand goals of getting computers to converse like people and getting them to possess common sense of the sort that people have. And some of the icons I associate with that quest are up there. So besides Turing, there is John McCarthy, who has been an advocate of using logical representations and reasoning methods for common sense, besides being one of the founders of artificial intelligence. And Roger Schenck, who was the first to really clearly and convincingly articulate the need for large amounts of knowledge about the world, about people and about action and so on in understanding language, and also offering representations of that knowledge both at the level of propositions and at the coarser-grained level in the form of scripts and the like, which I'll be coming back to. So if one is interested in that grand challenge, then one is confronted by a number of challenges that I've bulleted out here. So the first is, how do you represent these large amounts of knowledge and these diverse and rich kinds of knowledge that we are able to articulate and reason with? Secondly, how, once we've represented that knowledge, do we in fact reason with it in order to understand language, to produce language, and to make common sense inferences? And then, of course, the third is, how do we acquire this very large amount of knowledge? The knowledge acquisition bottleneck confronts us. So I'll be touching on those three challenge areas with emphasis on the last. And in particular, I want to talk about trying to get this large amount of knowledge out of the vast amount of text accessible to us nowadays out there in electronic form. And there, a number of sub-issues have to be confronted. One of those is that language itself, to be understood, requires knowledge. And so if we're trying to get knowledge from language, don't we already have to have knowledge to make sense of the language and hence to get out knowledge. So there's a bootstrap problem here to be confronted. And then there's the problem that there are various ambiguities and underspecification problems with any knowledge that you get out of language in the first place. And I'll be enumerating some of these difficulties and talking about ways of approaching them. And then I'll talk about the technical issue of donkey anaphora, which are not that well known in either the knowledge representation and reasoning community or the computational linguistic community. Not totally unknown, but not that familiar. It has to do with using referring expressions that refer back into negative environments. And I'll, of course, be explaining exactly what is meant by that problem. So, in fact, my emphasis will be on that. So, this first picture here actually touches on both of the big bullets that I had on the last slide, namely the representation of knowledge and its use for inference. So we've been working on a representation that is intended to be a natural logic, comparable in expressiveness to language itself, natural languages themselves, and that's episodic logic, EL. Jason already mentioned this. And the epilogue system is the inference engine that we've been concurrently working on for a long time, intended to be able to reason with this kind of knowledge. So this is an example of a simple sentence here: a car crashed into a tree, and how it is represented in episodic logic. And you can think of this for the moment as roughly first order logic with some bells and whistles. So basically we're saying here that there exists this event E, it's before now, and there's this car X and the tree Y, and X crashes into Y, and that predication, that statement, characterizes the event E. So this double star is a characterization relation, and there is a semantics for that. And so beneath that we have the inference engine. So that consists of a core part that does reasoning in episodic logic, and it's also connected through a uniform interface to a set of specialists, general purpose specialists, that support the reasoner in particular areas such as taxonomic reasoning, which people do very efficiently, temporal reasoning, and reasoning about parts and colors and other things that seem to come very naturally to people. We would also like to have an imagistic reasoning specialist in there, but as yet we don't. So suppose that now in this epilogue core we have, as part of the knowledge base, that when a car crashes into a tree, then the driver of the car may well be hurt or killed. That's straightforwardly representable. It's an example of a generic sentence, a piece of generic knowledge. If we have that in there, then we'll be able to get that logical output that, in fact, the driver of X may be hurt or killed. So that's the kind of inference that we want to have a sufficient knowledge base to get out of epilogue, and we'd like to be able to do that about the whole range of things that people know about as common sense knowledge, and that they bring to bear in language understanding and reasoning. Now, there are some additional bells and whistles, as I said, in episodic logic, and these include generalized quantifiers, and there's an example here of how one can directly reason with generalized quantifiers like most and no and things like many and few and so on. And then, as indicated in that example above, we can directly express the characterization of an event by a sentence. And of course, events and causal relations and temporal relations are very important in language. And then we also allow for modification and reification of various sorts, because that's something available in all human languages. And this last sentence down here illustrates a couple of these phenomena, like modification of the verb phrase maintains that aardvarks are nearly extinct by an adverbial. So you can think of the adverbial as an operator that maps a verbal predicate, a sentence predicate, into another sentence predicate. And so it transforms a predicate into a more restrictive predicate. And there's a lot of that goes on in language. And the object of maintains here is the sentence that aardvarks are nearly extinct, and the that operator you can think of as a reifying operator, an operator that turns the meaning of that sentence into a thing that we can talk about. And so that enables us to use propositional attitudes, so-called, like believing and maintaining and fearing and doubting and so on in the language, among other so-called intentional constructions. So I don't have much time to talk about epilogue, but this is just a slide about the recent work of Fabrizio Morbini, who has just finished his doctorate. And primarily his emphasis was on improving, well, the system as a whole, making it more transparent and extensible, and also enabling it to do self-referential reasoning in the sense that it can reason about not only itself as an entity, but what knowledge it possesses and what kinds of knowledge it possesses, what knowledge it doesn't have, and to use that kind of knowledge in its common sense inferencing. And this also enables to a kind of self-awareness, and we have a little self-awareness demo that illustrates how the system can talk about itself and talk about what it has been talking about with you and so on. But these are just some examples in green here of the kinds of common sense questions that the system is able to answer if you provide the appropriate knowledge to do so. And some of these are made up by us, and some of them are from the Psych challenge set. They have 1,000+ common sense questions that they provide as a challenge set, and some of which they have answered with Psych, some they have not. So I just want to mention a couple more things that, first of all, this self-referential ability also enables the system to invoke procedures in a kind of deliberate way. So it can invoke a specialist by reasoning that this specialist can help it with its other reasoning task, for which the specialist is particularly well suited. And the other thing I wanted to mention is that there's this myth, I say, out there in the knowledge representation and reasoning community, that if you have a very expressive representation, then you're stuck with computational intractability that keeps you from doing any serious inferencing. And the way that Fabrizio brought evidence against this claim was by running his refurbished version of Epilogue on a challenge set, a large challenge set that is being used by the theorem proving community to test first order logic theorem provers. And so he was running on a data set that the very best theorem provers, current theorem provers developed over decades, have been designed to function very well on. And he held his own. He did not beat all the other systems, but without modifying his Epilogue system at all, it held its own against the best theorem provers. And so this illustrates that really you can have expressivity, which enables you to do things that you cannot do in less expressive language without sacrificing tractability in a practical sense. Okay, so now I want to talk about knowledge acquisition and the knowledge acquisition bottleneck, which for me really consists of two categories, namely acquiring shallow knowledge, knowledge which is really at the level of sort of predicate argument patterns or modifier and operand patterns, often the operand being a predicate or a sentence. And so that's one kind of knowledge that I think is essential, particularly for language understanding. And then there is the knowledge we also need for deeper reasoning. And just to illustrate the kinds of assistance we can get from pattern-like knowledge in language understanding, consider familiar terms like so-and-so is a legend, a tennis legend or a football legend or something of that sort, which is not the same as saying he's a tennis story. And how do we know that? Well, simply because that's familiar phrasing, that combination of a sport and being a legend or being an ace or a star or something of that sort. And likewise, making friends with someone is not the same as creating friends with someone, even though making and creating are quite similar terms in meaning in many cases. And again, it's because we just know this combination of predicates and operands. And then there, of course, is the problem of syntactic ambiguity. We don't want to conclude from the sentence that the bird had binoculars, or conversely, for the parallel sentence, I saw the bird with yellow tail feathers, you do want to conclude that the bird has yellow tail feathers. And so how does general knowledge help? Well, we know that seeing is often or sometimes done with a viewing instrument. And so that combination registers with us, and that's why we make the correct attachment. And similarly, in the case of the bird and yellow tail feathers, we know about birds having feathers, and that's what attunes us to that particular attachment and makes us favor it. So we, of course, also need deeper knowledge, such as lexical knowledge, diamonds are precious stones, or world knowledge, such as diamonds are the hardest material, and that houses usually have a front door through which you can enter, and then lengthier stories, and that's more like a generic passage, as I was saying, that when people dine at a restaurant, they enter and find a table to sit at and make a selection from a menu and so on, and that's getting us into the kind of story that Schenck was very much concerned with in his work, and that I'll be getting to later. So the knowledge extraction method that we've been using is one that's based on parsing. And so and in that respect, it differs from most of the work that's out there, which is mostly based on using extraction patterns to target particular kinds of knowledge, or using collocations to pull out relations. And what we're doing is finding a sentential parse, using compositional interpretive rules to obtain a logical form for a sentence. Compositional rules are ones where a phrase structure rule is paired with a particular interpretive rules, and that enables you to compose the logical form of the sentence. And then from that logical form, we abstract propositional pieces that look promising as general propositions. We do some abstraction from particular terms to general terms and throwing away of modifiers to get sort of core knowledge. And so then we get the sorts of things that are listed here. Once the logical representations, these are underspecified logical forms, are mapped automatically into approximate English. And we have many millions of these from the British National Corpus, from web blogs, and from Wikipedia, and so on. Now the problem, as you saw from the examples on the previous slide already, is that these are rather weak pieces of knowledge, as knowledge goes. They are factoids that kind of give you a possibilistic view of the world. That, for instance, a room may have a window, a mouse may have a tail, and so on. And what we can get out of that in terms of inference is not very much. Perhaps, given a room, you might say, well, it's a good possibility that it has a window. Or given a mouse, there's a good chance it has a tail. But nothing more than that. What we'd really like is something stronger from which we can make inference. You want if-then statements, quantified if-then statements, where you can plug something into the antecedent and conclude the consequent. So what we want is knowledge of this form. So a room of a dwelling usually has a window. So this now is a generic sentence. And it's tacitly of conditional form. That is, you can think of it as saying, if X is a room of a dwelling, then usually X has a window. And similarly with the mouse and the tail and the other examples about crashing and the bad consequences of that, where we would like to make the corresponding inferences in particular cases. So how do we do that? Well, so first of all, there are a number of bootstrapping methods that we've been working on. And three general approaches are listed here. So one is to bundle together classes of related factoids that allow us then to abstract something stronger. And I've indicated an example there, and I'll be coming back to that. And you can also strengthen some individual factoids. So if you have that an elm tree may have a branch, maybe you can conclude that all elm trees have branches, or at least most of them do. And maybe even abstract a little further and conclude that most trees have branches. And for that you need lexical knowledge, so that's something we're working on. And then you may also be able to boost the performance of your parser to get higher accuracy. I should mention that the best current parsers still get virtually every sentence long if it's 20 or more words. And so we need to boost parser performance to get more accurate interpretation. We can get the logical form approximately right if we get the right parse. Now this particular example we can handle. A car crashed into a tree, the driver died instantly. So from pairs of clauses or complex clauses, you can get more powerful knowledge potentially about causal relations and the like. But it does require better parsing. Then we also would like to interpret directly. That's really the most immediate temptation, because there's all kinds of directly expressed general knowledge out there. Open mind, common sense contains a lot of general pieces of knowledge. And these are some examples here. I might say they have been selected to be relatively good examples. It's actually rather disappointing how bad most of them are. And then there's Wikipedia and WordNet glosses. They tend to be better, but they tend to be phrased in a way which is difficult to deal with and difficult to parse. And then there's, of course, just teaching by telling. And if I were to say things to the machine to get approximately correct interpretations, that's the kind of thing that I would be saying. But no matter how you approach it, you're going to have a variety of difficulties. And the first four of these are all concerned with ambiguity and underspecification. And so first of all, as I already mentioned, there's syntactic ambiguity, as in the case of the bird with binoculars or tail feathers. And then there's semantic ambiguity, as in journalists write articles. Well, what kinds of articles are we talking about? I'll come back to that example. I'll briefly talk about each of these, but not at length. And sure.
The bootstrapping.
Okay.
You mentioned that if I see a statement in text somewhere about houses having windows, then you're only willing to infer that houses may have windows, and then you
Yes.
need additional evidence to strengthen it to saying houses usually have windows.
Well, so when we look at the text that's out there in abundance. We don't really find houses have windows. What we find is he went up to the house, the window was broken, or something like that. Or he was sitting in he was in his house, and as he looked out the window, things like that. So we get, particular instances, and from those you don't have the general information that houses have windows. That's the problem.
Right. No, but what I'm thinking is that these statements actually imply more than the assertion that houses occasionally or may have windows. Because let's say that houses occasionally had windows, but not usually.
Mm-hmm.
Then you'd often see something like the house had a window, and he was looking out of the window, as opposed to he was looking out of the window, because it's assumed in that sentence that the fact that the house had a window is not a surprising thing to you. As a reader.
Right.
You're saying that the window isn't inferable, and so there must be one.
No, the fact that its existence hasn't been explicitly asserted, and it's used the very first time as if the reader knows it's there.
It's called inferable.
That is usual.
Yeah, to some extent, yeah. I mean, one can use presuppositional knowledge to some extent, and I think that's a good point. But you do also get things like, he walked into the corridor, or let's say into the. Let me think of the right kind of example. Into the living room. He walked into the living room. The chandelier was gorgeous. So you can perfectly well have an unusual object referred to definitely, simply because you can use the definite as long as that kind of thing does, in some cases, go with that kind of object. So, there's no assurance really of it happening often. So we have to be careful in what we conclude. So then there's temporal ambiguity. So when you say ducks fly, this seems to apply to sort of a large time span, not just present-day ducks. And on the other hand, if you say dogs are barking outside, it seems to be about a particular set of dogs. And if you say people worry about the economy, well, that seems ambiguous. So maybe it's something that people generally do, they're disposed to do, or maybe they're just worrying right now because of the financial crisis or something like that. Then there's quantificational ambiguity. When you say bears are dangerous, do we mean it's rarely dangerous? Do we mean it's a rare bear that's dangerous, or do we mean that bears in general, at few times of the year, let's say, are dangerous? So it could be temporal or atemporal. And then there's drastic underspecification. If we say cats land on their feet, we surely don't mean they're doing this all the time, so there's something important missing here, and similarly for the school children example that's underneath. And then there's donkey anaphora, which is exemplified by if a farmer owns a donkey, he usually beats it. Now, you see that here we have pronouns that refer back into a negative context, namely the farmer and the donkey. It's a negative context because in a sentence of form, if A then B, is equivalent to not A or B, and so you see that the A part is in a negative environment. So I'll be spending a fair amount of time on that, I think. So briefly about each of these issues. So I've already mentioned that one of the approaches to dealing with syntactic ambiguity is to use factoids such as that one may see things with binoculars, and these are factoids that we've actually got. And so you can bias your readings using these factoids to favor one interpretation, one attachment or another. And then there are also the sense disambiguation problems. I talked about tennis legend. Well, if in your collection of factoids you also have tennis stars and aces and sensations, and you find that in a lexicon you have a common sense for these terms, then you can guess that all of these senses are intended in that particular sense. Now, sometimes all of these words are intended in that particular sense. And sometimes you can do the same kind of thing a little more indirectly as well. I should mention that some of the things I've been talking about have been very much contributed to by Ben van Derme, and this is one of the examples, and that's primarily his work. And what we're looking at here is a couple of factoids that are both about writing, in one case writing a letter, in another case writing an article, and each of these has multiple meanings in WordNet, but if you abstract, if you move upward in the WordNet hierarchy, then you get to a particular hypernym here, communication, a sense of that term, that subsumes both of these objects, and you can therefore reasonably guess that letter and article in these sentences are both intended in the sense of a communication. And that has proved to be quite successful. And you also get, in addition, a piece of generic knowledge out of that, in this case, that if X writes Y, then Y is probably a communication. So secondly, temporal ambiguity. Now, I'm certainly not telling you solutions to all of these problems. What I'm doing is I'm telling you about some concepts and ideas that really seem to have some leverage with these problems, that give you a handle on them and seem to point to a way to a solution. So in this case, the essential ideas come from Greg Carlson, temporal ambiguity. He distinguishes between individual level and stage level predicates. And the individual level predicates are the ones that are sort of durable. Things like being a person or being smart. Those are individual level predicates. But on the other hand, barking or walking and things of that nature are stage level predicates. They apply to a phase of an individual or a stage of an individual. And by making that distinction, one can come up with reasonable interpretations of sentences that are in the present tense. And so in the first case, we're using an individual level predicate. The ability to fly is individual level, and therefore that becomes a generic sentence, generically interpreted over a long time span, potentially. Whereas if you say ducks are flying south, then it might be just about this time of year and not about what ducks generally do. On the other hand, as you see in the third sentence, we do have this ambiguity, and that's due to another phenomenon of language, that there are hidden operators that shift the type of a particular predicate or other operand. And in this case, what we have is a kind of hidden habitually operator, which is particularly to be expected if you have a simple present sentence for a stage level predicate like worry. Worry is stage level, but it's being used in the simple present, and that suggests that probably a reasonable insertion here is a habitually operator that makes this into an individual level predicate. And if we do that, then we get a reading like ducks can fly, that this is something generic about people over extended time spans. Don't worry about the formal details. I'm just giving indications here. Yeah?
Can you go into what you mean by stage level?
So stage level is something that applies briefly. Usually it's an activity rather than sort of a static property that holds over a lengthy span of an individual's life, existence. Okay, like walking or talking. These are, things that just hold transiently of an individual and not over a long time span.
So individual level would be ducks can fly, stage level.
So can fly is an individual level predicate, is intelligent, is a person, owns a horse, that kind of thing. So if you have farmers own horses, or even John owned a horse, you kind of expect that's over a considerable length of time by default anyway. So on quantificational ambiguity, again, Greg Carlson's work, he's a linguistic semanticist at the University of Rochester, is criterial. So how do we get these various readings of bears are rarely dangerous? Well, one of the factors is that quantifying adverbs like rarely or usually or sometimes can have both an atemporal understanding and a temporal understanding. So if I say to you, oranges from Florida are usually delicious, right? I mean that most of them are delicious. It's an atemporal understanding. I don't mean taking a random orange from Florida, it's going to spend most of its time being delicious, right? It's not a temporal qualification. On the other hand, if I say cats are usually asleep, then in fact I'm doing a temporal quantification on the preferred reading. I am saying take your average cat and most of the time it's asleep. So that distinction between the temporal and atemporal readings of the adverbs is criterial here. And there's another distinction that actually leads to additional readings. There are both kind-level predicates and object-level predicates. So objects are things like people and glasses and clouds and so on. And kinds are species, kinds of things. So when you say dodos are extinct, you're applying a kind-level predicate to the species dodos. Or when you say the H1N1 virus is evolving, evolving happens to be a stage-level predicate over kinds. And so you have to distinguish both that stage individual level and the kind object, which is kind of orthogonal to that, the kind object distinction. So both of these distinctions play a role here because dangerous can be both. So when you say, for instance, that locusts are dangerous, you don't mean an individual locust is dangerous. You mean collectively they're dangerous. If you say tigers are dangerous, you may well mean that individual tigers are dangerous. And so that gives rise to additional ambiguities here, and I've simply shown one of the readings, which is the one that few bears are dangerous down here, and that sort of comes out of these alternative interpretations of the terms. Okay, and then there's drastic underspecification, as in the case of cats land on their feet. And there we have to be aware that we need presuppositional information that has to be brought into the representation of a generic sentence in order to really make genuine sense of it. And these presuppositional pieces come from at least two sources, namely lexical presuppositions and pragmatic presuppositions. So landing, for example, presupposes dropping to a landing surface. So that what you might flesh this out to is that when a cat drops to a landing surface, it lands on its feet. But there's also a pragmatic presupposition which is particularly apparent if you emphasize feet. If you say cats land on their feet, then there's a pragmatic presupposition that when cats land somehow or other, they land on their feet. And so one can inject these presuppositions into the generic sentences to flesh them out. There's also world knowledge that has to be brought into the picture in many cases. So when you say that critics rarely find movies flawless, which is really a quantification over movies, not over critics, the knowledge you need to bring to bear is that in order to critique a movie, you have to watch it. And so we really want to flesh this out to something like when critics watch a movie, in rare cases do they find it flawless. So all of that is just an indication that there are approaches to these problems. And I want to get to Donkey now for a now. And
a couple of things that so
Okay?
The last example was a particular case of it, that it's often not even clear cut which is intended. When you say
Yes.
it's rarely
Exactly.
movie flawless,
Yes.
it could very well be referring to one movie which most critics didn't like for some reason or the other, and it's the fact that when you have an ensemble of critics, most of them will find flaws with it. There will be one who doesn't.
Yes, yes, there are all of these possibilities. And in fact, additional technical possibilities arise from how one quantifies over the subject as well. And so, again, one can do this in terms of various hidden operators. So there's the habitual operator, and there's also a type-shifting operator with essentially raises predication to kinds. And so it's not that, yeah, so these multiple alternatives can all, in a particular context, come to the foreground and be the intended understanding. And that's a separate problem. But we at least want to be able to represent the various alternatives.
Okay, so the representation starts to make sense now. And then I have another question. When it came to things like making friends is not the same thing as creating friends, I thought one of the things you're implying by your example is that you'll find, although make and create may be equivalent in some sense, you'll not find text examples of creating friends, whereas you will find several examples in the text of making friends.
Exactly.
So in that sense, what kind of evidence would we look for to decide that it's the occasional bear that is it's an occasional time that a bear is dangerous, and not that it's an occasional bear that's dangerous, or vice versa? What kind of text would substantiate that?
Well, yes, you're asking about the pragmatic disambiguation and world knowledge-based disambiguation. So, I mean, we often talk about dangerous animals,
Okay,
right?
So you assume that some bears can be dangerous.
Yeah, we're familiar with the notion of particular animals being dangerous. But we also, for instance, in the case of the locusts, have particular knowledge that a small insect, unless it has a poisonous sting, is not going to be particularly dangerous. And so we bring world knowledge into the picture to sort out the particular interpretation that we want to take out of a given sentence in a given context.
Okay, so this will have to come by bootstrap, so the raw text may not clarify.
Certainly, yes. So donkey anaphora were first extensively written about by Geach in 1962. And here's the farmer and the donkey again. And it's referred to as donkey anaphora simply because those were the kinds of examples that Geach used. But basically, as I was saying, generic knowledge really typically takes this form of a conditional sentence where we have some referring terms, such as a pronoun or a definite noun phrase, in the consequent or in the main clause that appears in the antecedent clause. And that gives rise to donkey anaphora. So this has not been paid much attention to because it doesn't occur in most of the stuff that's out there. Most of the text that just describes what happened in the world, or the news, and or even things that happen in fiction and that might be found in descriptions of merchandise and so on. They are all particular things. And donkey anaphora just doesn't happen very much in that kind of text. But it's pervasive in general knowledge. And so it's really important to be able to handle it. Excuse me. So what's the problem? Well, let's take a generic sentence like that first one about the farmer and the donkey and just write down a logical form for it in episodic logic. So we have that given a situation E in which there is a farmer X and a donkey Y, and the situation E is characterized by X owning Y, usually for that type of situation, X beats Y. So that seems to kind of at a glance capture the correct sense of what we've got up here. But the problem is that x and y here occur outside the scopes of these quantifiers, and therefore they're free variables that are not interpretable in ordinary logic. And so that's a difficulty. Now, the scopes of these quantifiers are confined to the antecedent because the antecedent sentence is a complete sentence. A farmer owns a donkey, right? And if in a logic class you were writing this down as a formal sentence, you'd say there exists an X, there exists a Y, and one is a farmer and one is a donkey, and X owns Y. And that's just the way it comes out. And yet we want to refer to this later. And we end up with this kind of strict nonsense from a first-order logic point of view. So,
you explained the double star, the @ sign here?
right, that's what I mentioned before as the characterization relation. So if you're familiar...
I'm asking about the @ sign.
Oh, the @ sign. Oh, okay. Yeah, that's kind of a... it's related to this, and it means that there exists an episode which is concurrent with one that this sentence characterizes. So you can think of it, X beats Y during E, or over the span of E.
So it's like there exists an F which overlaps with E such that X beats Y star star F.
It actually extends throughout E, yes. Yeah, it's concurrent. Yeah, correct. It's just a matter of convenience, so it's in that sense, it's an abbreviation. So how do we get around this problem? And this occurs in all the other examples as well. So this has exercised linguists for a long time. And initially, the kinds of suggestions that were made were that these pronouns are really lazy abbreviations of some lengthier description. But that didn't really stand the test of time. Well, there's still some approaches along those lines. But the prevailing view became that you need a dynamic semantics. And
just as a translation problem in introductory logic, forget about the usually, you would understand that as the universally quantified conditional.
well, you can't forget about the usually. That's the issue. So if you were to take, move these existentials out of their negative environment and make them universal quantifiers, right? So if you now have the universal quantifiers out here, what you're then saying is, okay, take this farmer X and take this donkey Y, and now I want to make a universal statement about them. I'm going to make a universal statement about them. Namely, usually when X owns Y, X beats Y. But now usually makes no sense at all because it may be that farmers own at most one donkey. And then the idea of usually this particular X owning this particular Y or beating this particular Y makes no sense. So that extraction actually does not work for generically quantified sentences. There are other problems with it which I'll be glad to talk to you about. It's a good observation and one that has been discussed in the literature. So let me just briefly say what the dynamic solution is that is usually proposed. This is really borrowed from computer science, and the idea is that you treat an existential as essentially a non-deterministic assignment. And so you're treating an existential statement as a kind of test, and the statement successfully executes if you can find an assignment to X and Y which makes the body of the test true. And then if that succeeds, you can go on to the next statement, and now X and Y will retain the values that they got in the previous statement, and so you will get the correct reading here. And these theories down here, discourse representation theory, dynamic predicate logic, and similar approaches are all of that general character. But they all have a flaw, which is that they lead to making the meanings of the clauses that you have in your knowledge base context dependent. And this destroys modularity for inference purposes. So you can see that even in a simple case like John has a donkey, he beats it. Now, he beats it is going to come out as John beats X. But you cannot use that in isolation because X has no meaning in isolation. It only has a meaning in the context of the prior sentence. And so, while logics have been developed by Hans Kamp and Uwe Reile for reasoning with these discourse representation structures that kind of keep the context around, it's not really, from my perspective, what we want for AI applications, where we kind of want random access to the pieces of knowledge in their smallest form that we can use in various contexts without having to worry about where they came from. And so this is a real difficulty from an AI perspective, and yet it hasn't worried people all that much when they haven't concerned themselves with generic knowledge. And I'll say why. Jason?
Yeah, so I'm trying to understand why you think that the lack of modularity there is a problem. If I state something under the scope of I believe or something else, it's also you can't just use it independent of that context, but that doesn't seem to be something that you can.
That's a different thing. So, yeah. So if it's subsumed under a particular, if it's part of another proposition,
right. Well, that's
the asserted.
Also, where it's under.
It's not an asserted.
Quantifier.
Yeah, it's not an asserted proposition.
Yeah,
right?
exactly.
But
So
in this case, we have an asserted proposition. In the simple example I gave, John has a donkey. He beats it. Right? The he beats it is just a separate assertion.
Well, suppose I say every Englishman has a donkey, he beats it. Which I can do, and I think Carlson has talked about this kind of thing in the context of generics and here.
Right. Basically,
explicit quantifier.
I mean, basically, you get this subordination that you have to work into the representation. That is, you basically have to extend the scope of the quantifier over this entire thing.
That's right. But then I can't take. I mean, clearly, I can't take the he beats it out of context, and I don't see why I would want to because I would change the meaning. So maybe this will become clear when you do this slide. The question's pretty short.
Yeah, maybe it will. So, one of the things that Carlson has worked on with Beverly Spejewski is generic passages.
Yes.
And I've looked at that in detail. And basically, it turns out he has to import, or they have to import, a lot of material repetitively into the antecedents of their quantifiers in order to be able to deal correctly with the references.
Right, but the amount that they have to, I mean, I guess what I'm saying is that the amount of additional context that you have to add is bounded by the scope of the quantifiers involved or the length of the generic passage or whatever. And so when you say it breaks the modularity, at least,
Yeah. Well,
it doesn't mean that you have to take this that you have to take something into account in your current interpretative context. When you're using a piece of knowledge from the database, it may be a heavily contextualized piece of knowledge, but it's contextualized by the context that you got it from, not by the context in which you're using it. And the context from which you got it from is bounded by something, and maybe the bounds are too big for comfort, but that doesn't prevent you from storing it in the database in some wrapped up form.
Well, sure, but that's the key point about bounded for comfort. That is, it gets really, really quite unpleasant when you have to import this contextual knowledge in the context in which you're using it. Things really get simple in what I'm suggesting here, so that really, I think, is a help. So,
let me ask you another question related to, I think, what Jason is asking, but maybe not, because I'm not familiar with the terminology of logical formulation. I was thinking about the example, maybe not, let's take something different from bears are usually dangerous, something like dogs are usually friendly. So there you talked about how usually has this way of, there's ambiguity, of course, about whether it's about all dogs or about every dog over most times and so on.
Yes.
But why can't this example of if X farmer owns donkey, usually X beats Y. So treat it that way, saying that it's still if A then B, it's then usually B. wouldn't that be an alternate way of interpreting that sentence representative?
Well, then it's not clear what the usually quantifies over. And we
But it
can
has the
say
same ambiguity
we can
as-
say that in English, right? So you can use usually as a modifier of the verb phrase,
Right.
but semantically it really quantifies the sentence as a
No,
whole.
but I'm saying that then it falls in the same category as the previous ones, and then it's no different from dogs are usually friendly.
I don't think I'm quite following that.
Okay.
So
I'm
so
saying-
maybe,
Yeah, okay, maybe
yeah.
we'll take it offline.
Yeah.
We'll probably meet you afterwards.
Yeah. Okay. So why are computational linguists and knowledge representation people generally not troubled by this problem? Well, because they rarely deal with conditional sentences of this form, in contrast with the case of generic sentences. And so let's just see how it goes in that case, typically in a computational linguistic approach. So if you have John owns a donkey, he beats it, how would you represent it? Well, you have this existential sentence where you have the beating event, and there's the rest of it in episodic logic, and now you have he beats it, and so there's another event, which is the beating event. Now the he, of course, is easily interpreted as the name John, because we have a name for the agent of this beating. But in the case of it, we don't have a name, we just have an existentially quantified y here. So of course what we do is we skolemize. That is, we dub the donkey with some particular name, and that's the Skolem constant. We invent for it some name different from the constants we're already using, and this then enables us to also refer to the donkey with the same, in the same way as to John, namely with a name. And so that's the beauty of Skolemization. Now, intuitively, the example of if John owns a donkey, he beats it, is really not very different from John has a donkey, he beats it. And so one feels that one should be able to really use something equally simple in the case of conditional sentences and this reference into a negative context. But if we do that, then we seem to get into trouble. So consider a non-generic sentence. If John found a sturdy donkey at the fair yesterday, he bought it. Then let's just write that down. And so now we have, instead of an and, we have an implication sign here. And let's just do the Skolemization as if we were allowed to do it, which we know we're not allowed to do, in the negative environment here. And so we introduce this event constant and the donkey constant, and then just use these things afterwards. So what's wrong with that? Well, unfortunately, this sentence can be true in circumstances where it intuitively ought to be false. So consider a situation where John in fact found a number of sturdy donkeys, but he didn't buy any of them. Then surely that sentence is false. That if he found a sturdy donkey, he bought it. However, this formal representation isn't necessarily false, because, this one here, because under those circumstances, because after all, we haven't constrained y1 to be a donkey. We haven't constrained e1 to be before now. And so you can get a false antecedent in a trivial way, and that gives you a trivial truth, because a sentence, a conditional sentence with a false antecedent is trivially true. If I say, if the moon is made of green cheese, then I'm a billionaire, then that's true simply in virtue of the falsity of the antecedent. It's trivially true. Now that observation, though, also points a way to a possible solution. Yes?
Where is that antecedent in here?
The antecedent is this entire thing in front of the arrow.
And which part of that can be false?
If any one of these is false, then the entire antecedent being conjunctive is false. And so the entire formula, the conditional formula, is true.
So, okay, so what you're saying is if, okay, got it. So the sentence if John found dirty donkey, he usually uses to. Okay, I got it. I thought you were trying to say something.
Let me see if I can paraphrase. This sentence is true if there is some y1 such that it's true, and I'm going to exhibit such a y1, namely the mood. So, you know, if the mood is a sturdy donkey and John found it, then John bought it. That's true,
I see.
because the mood isn't a sturdy donkey.
Right,
Okay, paraphrase?
that's roughly right. Yeah, I mean, you are kind of universally quantifying over possible interpretations of the constant y, y1.
No,
and
I'm
we're-
just
we're-
exhibiting one, because the idea is that the Skolemization
Okay,
constants are
okay,
existential.
exactly, okay.
Right. And I'm showing that the sentence is true by exhibiting a witness.
Oh, okay,
Yeah,
fine,
yeah.
yes, then that's exactly right, okay. So, so that's not a good solution.
There's the mood.
Exactly. And so we see, though, what the problem is, which is that this antecedent can be trivially false, making the conditional trivially true. And so let's just make sure that the antecedent cannot be trivially false by postulating, stipulating a separate sentence that says that the antecedent cannot be trivially false. That is, we say that if there exists a time or an event and a donkey such that John finds the donkey in that event, then the constants have to satisfy this same propositional frame. They have to be constants of the right kind, that denote the right things. Right, so then you have made sure that you cannot have a trivial antecedent here, and so with that stipulation, we're in business, and we're doing it in a way that avoids dynamic logic, which I want to avoid.
For the weak reading.
For the weak reading, yes. Yeah, I'm not intending to talk about the strong reading, but maybe in the question period, or if you like. Let's look at the quantified cases. We can generalize to the case where the existential is within a quantificational context, and therefore we want a Skolem function. And again, in a case like every farmer in Smallville owns a donkey, we would just Skolemize if we're doing resolution principal theorem proving or something like that. So for every farmer, the function that we introduce for the donkey will pick out the donkey that the farmer owns. And so in the consequent here, they all beat their donkey. You're again quantifying over the farmers. And in this case now, their donkey can just be represented as that function that we created applied to that farmer. And so we get the correct interpretation. These are slightly simpler examples that I'll use for illustration. Every man has a gun, and many men use it. And so that's a simple conjunctive case. And here again, we can use the straightforward Skolemization, but we're in trouble in the conditional case. If every man has a gun, many men use it. And because we're again making reference into a negated environment, in effect. And so I've shown sort of both cases here, the logical form, and what happens when we Skolemize appears down here. But for the case where we're using the conditional connective, we have to posit the Skolem conditional, which again ensures that we do not have trivial truth of these antecedents. So we're saying, since we're quantifying over all men here, we're saying that, take any man, and now we're going to ensure that if in fact for this man there is a gun that he has, then y1 shall apply to x shall be such a gun that he has. And it works in the converse direction as well. It's essentially a definition, because by existential generalization you also can go from right to left here. So there's just some generalities now to be stated. In general, when we have existential sentence with a restricted quantifier, these are basically conjunctively combined. And so what we want to do is take the conjunction of these and Skolemize them functionally. And we want to make them dependent on the free variables that occur in phi and psi here, because those will be the ones that are externally quantified and I'm presuming here by something other than existential quantifiers. And so these are the ones we want to make the independent variables in this, with respect to these functions, with respect to these Skolem functions. So that's the general statement. And after we have written down this conditional, which we could biconditionalize, we can then use the Skolemized form in the generic sentence. And so now I'm applying this in the case of a slightly more complicated story, a generic passage, which is again the restaurant story. So when we write that down in logical form, what we have here is a kind of restriction on an event type. So we have generally, for an event or situation of the following type, there is a person and there is a restaurant such as X dines at Y, and that characterizes the event type we're talking about. And then we say for that event type generally, we have some additional things. We have an entering event, we have a table, and a getting seated event, and so forth. So we can write all that down in logical form. And now since the restriction on the generic quantifier here is not creating a positive environment, we want to in fact assert the Skolem conditional based on that restriction. And so we say that for all E, this is now the only free variable in that restriction, for all E, if there's a person and a restaurant such that the person dines at that restaurant and that characterizes E, then the function x1 should pick out the person who's doing the dining in that event, and the y1 function should pick out the restaurant in that event. And so now we have these functions which we can use further in the body of this generic story or outside of it, as a matter of fact. So this is now the representation of that story when it's fully Skolemized. Now we have also Skolemized the main body of this generic passage, but in this case it's a straightforward matter of ordinary Skolemization because this is not a negative environment, it's a positive environment, so we can just introduce these Skolem functions of the generic variable E here, and we can use those outside of that context and within that context as well. And so the ability to use these Skolem functions outside the context provide a really nice device for dealing with a so-called bridging anaphora, where you say things like he went to the house and the window was broken, where you basically want to know that there is some kind of object you can pick out functionally given the house. And so if you've previously introduced knowledge that does that picking out and is formulated in terms of a Skolem function, then you've got an easy way to represent the referent of the definite description. And so here's the case of John dined at Mario's. His table was in the corner. Now how do we interpret his table? Well, if we go back to the restaurant knowledge, we find, oh, we have this table function for the dining event, so we can just pick out the table from that dining event. And similarly, we can pick out the restaurant itself. When we say the table was in the corner, of course, this has to be fleshed out pragmatically to the corner of something which from the restaurant knowledge might well be the restaurant. And so if that in fact is the correct referent, then we can represent it simply as that restaurant function applied to the dining event E. And so from this point on, there's just a sort of a couple of steps to tidy things up, providing a little bit of syntactic sugar in effect. Namely, we are repeating ourselves a little bit when we write down a Skolem conditional. So we're writing down the body of the existential once over here and again over here, just with the arguments written in a different way. And we're writing down this content once again when we use the Skolemized version in the generic sentence that we wanted to represent in the first place. So we're writing it down 3 times. And we'd prefer to just write it down once. So what we can do is, just for abbreviation, to introduce a predicate, which is a predicate of all the variables in the existential context, in the body of this existential, which, the scope of the existential, which are free in here. And we universally quantify over those free variables. And then, again, state the Skolem conditional. So this, in effect, provides a definition of the content of this existential context, and we force it to be equivalent to that context as well as to the Skolemized version. Now, this still contains two occurrences of the phi contents, but we can simply condense that statement into a schema that says we're defining this predicate pi, which has these variables x1 to xm, which has the Skolem functions f1 to fn, and then, by definition, this body supplies all of the details that we have up here. And we only write the f without its variables in that body, simply for conciseness. So then you are able to write down the content of the restrictor of the restaurant story by just saying, well, there's this predicate that I'm going to define. Person dines at restaurant. It's got the variable e, which is the dining event. It's got the Skolem function for the person and for the restaurant. And this is, in effect, providing the definition of this predicate, and also providing the definition of the Skolem functions, which we can subsequently use. And so down here, we can then use x1 and y1 in the body of this restaurant story. And if we want, we can also collapse these two things together and make a single generic script object, which again introduces the variable, introduces the functions that come from the existential, and also lists additional Skolem functions which come from the body of the conditional statement. Think of these as primary and secondary roles, and then basically the sentence that supplies the content of the original existential. And as it turns out, this is exactly the sort of way in which Wendy Lenhart, when she was working on scripts, characterized scripts. She had a script summary because she found that it was really essential in order to use scripts effectively in story understanding to have the basic statement about what really goes on in that script at the top. And so we have something that's very similar here to a Shankian script or to a frame. It's also very similar to what the sort of thing one might write down in a description logic. But we have, in comparison with Shankian scripts, we have a precise semantics, and we also have greater flexibility in what can go in the body of the script. And we have a way of getting from English, at least in principle, to this sort of logical form. So this opens the opportunity for just interpreting sentences that are general knowledge, that for us represent general knowledge about the world, directly into the computer in this sort of form. Question?
Yeah, this is just a quick technical question. In the second line of this, isn't there a type error with predicating person of x1? x1 is a function. Shouldn't that be x1e?
No, I was maybe said that too quickly, but we're leaving out the arguments in the definitional.
So just the gen script.
It's just, well, you know, it's frequently done in frames as well, where the frame variable does not appear in the role positions. So it's understood that the role is a function of the frame variables. Right, so we're just doing the same thing here. Just a conciseness trick, that's all.
So later on you did write x1e.
Exactly, we can, so, right, we're expanding it out in the body here.
But
Right.
not like
This is just the definitional part, yeah. Yeah, I mean, write them in if you like, it doesn't matter. Right? Or leave them all out here.
Thanks.
Right, okay.
Okay,
Yeah.
question two, so I can understand that question is, what information do all those lowercase e's provide? What does that represent? And
That's the event that we're quantifying over. So The gen here indicates we're using the generally quantification. Roughly that corresponds to most. So think of it as most events of a particular type. And the script just indicates that we're going to include a predicate definition here. And that's the information that defines that predicate and also defines the Skolen functions. So this is just a concise format for all of the stuff I wrote down before, just to show the direct analogy to scripts. Okay, I need to ask how much time I'm actually allowed.
Actually, we're a little over time.
Yeah, I was afraid of that. Okay, so I will try to be fast, so we can also add additional information about other kinds of restaurants, which normally have to be done with introducing different tracks in Shankian scripts, because the Skolen functions enable us to talk outside of the scripts themselves. And that's very convenient. So here's an example about fancy restaurants where we can then use, for instance, the table function to say that there is a tablecloth on the table in a fancy restaurant and things of that nature. And we can also briefly define the more specific notion of dining at a fancy restaurant. And so the conclusions are, first of all, based on what I've said about acquiring factoids, that we can obtain large numbers, many millions of underspecified factoids in logical form. And furthermore, these seem to be well suited for bootstrapping of various kinds, including parser bootstrapping. By the way, to some extent it has been tested in other places, Boeing to be specific. And we can also lump together groups of factoids to abstract something more general, as Ben van Dormy has done. And we can also interpret simple generic sentences if we can get the parser to do it right. And in more extensive interpretation of more complex conditionals or more complex declarative sentences out there on the web that in principle should enable abstraction of generalities. In all of these cases, we need to deal with these problems of ambiguity and underspecification, and these are just reminders of the sentences I use to illustrate these types of ambiguity and underspecification. And then there's the problem, and my point was that there are reasonable ideas for getting a handle on these problems. They are not mysteries, they're problems. And likewise for donkey anaphora, there seems to be a straightforward way of skolemizing even in these donkey situations, and thereby enabling reference in a convenient way outside of these generic contexts as well. So I'm optimistic about our ability to ultimately acquire large amounts of generic knowledge and using that for inference in a system like Epilogue.
When people grow up, they learn a large amount of generic knowledge before they even begin to use language.
Mm-hmm.
And they continue to learn that generic knowledge, independent of language.
Mm-hmm.
I wonder if you could comment on, sort of how that might fit into the problem, you're posing for yourself.
Yeah.
Learning only from text.
Right. Not only do kids come to language with a fair amount of generic knowledge, they're even born with innate capabilities such as object persistence and persistence of motion and things of that nature, not to mention various perhaps internal mentalese types at least, if not, certainly not explicit sentences, but certainly internal types, I believe. And learning algorithms of various kinds. So there's a lot of work to be done in understanding how that innate knowledge can be brought into the machine, and how the learning mechanisms that acquire the pre-linguistic knowledge can also be acquired by machines, and how that then interacts with the knowledge that can be learned from language. And hopefully these reinforce each other. That is, if you already have knowledge about the world from pre-linguistic experience, then presumably that is going to help with your understanding of language, bootstrap your understanding of language, and lead to success much more quickly than we can achieve success, with the methods we're using, at least up until we have the Turing child machine. But I don't know, I guess I'm in the same boat as everybody else there, but I don't know how, that learning at the early stages is really going to happen. Yes.
Is it correct to assume that, I don't know, but it's the fact that we're concentrated on ways of representing various meanings, right? But we downplayed the issue of heuristics that you need to bring to bear to recognize, for instance, even with the donkey sentences, the weak from the strong interpretation.
Yes.
So that's just a step in the overall process for the program that you understand.
That's certainly absolutely true. Yes. And it's interesting. I mean, there are certain heuristics one could use in distinguishing, in guessing that a reading is strong or weak. So, for instance, people tend to get a strong reading for a consequent in a negative context, I think. So if you say, if, or is it the weak reading? Let's say. Let's say if a man owns a donkey, he doesn't beat it. There we seem to get the strong reading. That is, if a man is a multiple donkey owner and he beats one of them, then that statement seems falsified in most people's minds. And yet in some cases of negation, we still get a weak reading. So if you have, if it rains outside, I won't forget my umbrella. Then even if I have multiple umbrellas, I'm not going to take them all along. So there, there's world knowledge that we also bring into the picture.
Yeah, but it needs to be brought into the picture.
But so there's a general bootstrapping problem that to properly understand the generic sentence, you often need world knowledge already. But that's the idea behind the whole process, that we bootstrap all the way.
Because you see, if indeed the issue with donkey anaphora is indeed to resolve the anaphora and not to advance a certain logic, then even such a simple heuristic as the closest antecedent that fits the grammatical constraints would work in 85% of the cases.
Right,
Not
but
that I advocate it.
Yeah.
I'm not advocating that, but still. And you in the first, one of the early slides, you said that there are specialists that deal with specific problems. So you could kind of...
We could have an anaphora specialist that uses whatever Hobbesian methods for anaphora resolution.
There are many,
But
many people.
sure. But still there are cases where you really need world knowledge, it seems. So if you say something like, he bumped against the sauce boat containing the raspberry syrup, spilling it, the it in that case refers to the raspberry syrup. If he knocked with his elbow against the sauce boat containing the raspberry syrup, knocking it over, right, then it's the sauce boat. So you really need to have world knowledge in a lot of cases. Yeah.
More work is needed.
Right.
Logic itself.
Right.